You're welcome back. So let's see how we can, in this video, we are going to be computing gamma of very simple numbers. So let's say you are to compute the gamma of gamma 1 now, using the formula gamma, let's say gamma n, which is equal to integral from 0 to infinity of exponential minus x raised to the power of n minus 1 dx. So we have to compute gamma where your n is equal to 1. So this is going to be 0 to infinity of exponential minus x raised to the power of 1 minus 1 dx. So this is implies that this is 0 integral from 0 to infinity of exponential minus x, because x raised to the power of 0 is going to give you 1. So this is the x. So now that means we are going to differentiate this function here. We are going to differentiate this function. Now if we differentiate this, we are going to have minus exponential minus x from 0 to infinity now, from 0 to infinity. So let's check this out. Now if you substitute the upper limit, you are going to have 0 most definitely. You are going to have 0 most definitely, because this is alpha gamma raised to the power of 0. So exponential raised to the power of infinity is going to give you 0. So let's now substitute the lower limit, which is going to give you exponential raised to the power of 0, which is going to give you 1. So if you open this bracket now, this will go 1 will go with 1, so you are going to have 1 remaining. So therefore gamma 1 is equal to 1. So let's look at gamma 2. Let's look at gamma 2 now. Gamma 2 is going to be integral from 0 to infinity of exponential minus x raised to the power of 2 minus 1 dx. So this is going to give us integral from 0 to infinity of exponential minus x of x dx. So this is what we are going to have. So let's take our v to be equal to x. The v is going to give us 1. Let's take our du to be equal to exponential x minus x. Then u is going to give us minus exponential minus x. So this was, so let's substitute into uv minus integral of u dv. This is from integration by parts. Let's substitute it in this formula. You are going to have now uv now is going to give you minus x exponential minus x. Then this minus integral from 0 to infinity of u. This is our u. U is minus exponential x, and dv is 1. So that means we're going to have minus exponential minus x dx. So this is going to be equal to, alright, so this is going to be equal to, so looking at this now, where we differentiated this is actually, this is actually 1 dx. This is 1 dx, but differentiating v with respect to x, so that's why we have dx here. So let's look at this now. This is going to, sorry, I omitted something here. This is supposed to be minus. Take limit from 0 to infinity. So if you take limit from 0 to infinity here, you substitute this in x, everything here will turn to 0. So automatically the whole of this first part is 0, and this minus will strike this minus, we are going to have plus. So you'll be left with integral from exponential minus x dx. Now if we check this now, this is the same thing with what we had here. This is the same thing with what we have here, and this gave us 1. So that means this will also give us 1. So that means gamma 2 is equal to gamma 1 equal to 1. But remember, even when we said gamma alpha plus 1 was equal to alpha gamma 1, do you remember this? Alpha gamma alpha. That means you add 1 to this, still going to give you the same thing. This is just exactly what we have here. So this is valid. and this is what we have. So because this was supposed to give us 1 plus 1, which is still equal to 1, which is equal to 1. So that is what we have here. This is what we have. So quickly, let's look at our third example here. This is 1, 2. Let's look at the third one now. 3. Now let's find gamma 3. Let's find gamma 3 here now. This is going to give us 0, integral from 0 to infinity of exponential minus x to the power of 3 minus 1 dx. This is integral from 0 to infinity of exponential minus x squared dx. Now v is equal to x squared, dv is equal to 2x dx, then du is equal to exponential minus x, then u is equal to minus exponential minus x. So let's substitute this in this formula as what we have. So gamma 3 will be equal to, now uv, now you are going to have minus x squared exponential minus x from 0 to infinity minus integral from 0 to infinity of u dv. This is our u, this is our dv. So this is minus 2x exponential minus x dx. So that is going to give us the whole of this. Of course, you know it will still give us 0. So this will go to 0. So let's solve this from here. So from here you are going to discover that this minus will go this minus. This 2 can come outside. Bring this 2 outside. You have exponential 0 to infinity of x exponential raised to of minus x dx. So now let's compare this with this. Compare this and this. Discover that they are the same, and this gave us 1. This is gamma 2, it gave us 1. So that means we are going to have 2 times 1, which is going to give us 2, which is going to give us 2. So that means this is what we have. Gamma 3 here is going to give us 2. But then let's use 2 factorial. Let's use 2 factorial. Now let me give you a general expression of gamma now. So now let's assume for gamma 4 now. What do you think gamma 4 will give us? Gamma 4 is going to be equal to 3 plus 1, which is going to be equal to what? 3 plus 1, which is going to be equal to what? This is going to be equal to 3 gamma 2. 3 gamma 2. And this is going to, 3 gamma 3. This is going to be equal to 3 gamma 3. And gamma 3 is 2. So this will be 3 times 2 here. Gamma 3 is 2. So this is going to be 3 times 2. And this is going to give us 6, which is equal to 3 factorial. So let's also look at gamma 5. Gamma 5 is going to give us 4 plus 1, which is going to, I'm using this formula now. Take note, I'm using this formula, which is going to give us 4 gamma 4. And this is going to give us 4 into 3 and into 6 here, which is 3 factorial. So let's just write 6. And this is going to give us what? 24. And 24 is equal to what? 24 is equal to 4 factorial. That is 4 times 3 times 2 equal to 24. So this is just how to, this is a recurrent formula. This is a recurrent formula for finding finding your gamma function. Now there's also one thing I want you to know. There's also one thing I want you to know, that this formula now is also equal to gamma n will also be equal to n minus 1 factorial. Gamma n will also be equal to n minus 1 factorial. So there are two expressions for this formula. You have, let's compare these two formulas with gamma 5. You have gamma 5 here. So gamma 5 is going to be equal to 5 minus 1 factorial
this other formula, we are going to have gamma 4 plus 1. This is going to be equal to 4 gamma 4. And this is going to be equal to 4 times gamma 4 is known to be 3 factorial, which is going to be 4 times 3 times 2, which is going to be 4 times 6, which is going to give you 24. So you discover that these formulas are the same. So generally we can say that gamma n, which is equal to n minus 1 factorial, is equal to gamma n, which is equal to n plus 1, which is equal to which is equal to n gamma n. So these are the formulas that you have. Thank you for watching to the end. Please subscribe to this YouTube channel and hit the notification bell to get updated each time we upload a video. Thank you.